Okay, hello everyone, welcome. Can you hear me?
Yeah,
Okay, just you're waiting 1 minute, then we'll start.
okay. Hi, sir.
Yeah,
Welcome.
welcome. How are you?
I'm okay. How are you, colleagues? Ali, Casey, hey. Happy to see you again.
Yeah, thank you. Okay, so we'll start this session. So hope all are you well. So basically today is our seventh number class, and I hope all of you already get all of previous recorded video class, and also get that all of materials. Okay, and also practice. So let's go. Let me share my screen. Then I start about today's session. Okay, can you see my screen? Is it visible?
Yes, we can see it.
Okay, thank you. So let's go. Okay, so basically today's session we discuss about that land use, land cover change detection. How we can easily make the change detection analysis using Google Earth Engine. We also discuss about that, as well as how to make the NDVI change detection. Basically NDVI for normalized difference vegetation index. So how we can easily use the different types of indices and make the change detection. We also discuss about that. And also NDVI classification based on the different types of trends. We also discuss about that. And how to extract the dense vegetation using thresholding technique. We also discuss. And class wise land use land cover change detection we also discuss. And calculate the transition land use land cover area. Okay, how much water body convert into build up, or how much vegetation convert into build up. So this type of transition, how we can easily calculate, we also discuss. And also discuss about that urban development and urban growth monitoring or urban expansion, how we can easily monitor the urban sprawl for the different decade. We also discuss about that. And final we discuss about that hyper parameter optimization. So how we can easily improve our accuracy and find out the best number of trees or best max node value, and then improving our machine learning accuracy. We also discuss about that this type of things. So let's go one by one. I try to explain all of topic, then I hope you can easily get the idea, and further you can also apply in your work. So let's go. Okay, so first of all, I try to discuss about the land use land cover change detection, how we can easily make the change detection over a specific time or a specific decade. So for that I already create the land use land cover classification for 2 decade in my region of interest. So here I make the land use land cover map for year of 2023, and also make the land use land cover map 2013. So now I want to make the change detection between these 2 decade. Okay, so this is the land use land cover map 2023, and this is the map 2013. Okay, this is the map for 2013. So I created 2-decade land use land cover map, and I try to classify vegetation area, water body, sand, and build up. Okay, so this 2-decade land use land cover map I created already using Landsat satellite imagery, mainly Landsat 8, and use the machine learning such as random forest. Okay, so I hope previous class I discussed about that how we can easily make the land use land cover classification using Google Earth Engine, use the different types of machine learning method, random forest or cart. So just I apply the same method, and then we try to classify land use land cover map 2013. This is the result for 2013, and this is the result for 2023. Okay, so now between these 2 decades we try to make the change analysis, how much build up area increasing, or how much build sand land decreasing, or how much water body. So this type of things I try to explain one by one, so then you can easily get the idea. So let's go try to discuss about that. So here you can say I already write the code for land use land cover classification for different decade. Okay, so I already write the code in here. Okay, same process. Okay, just we try to use the supervised learning. So we take the training sample. You can see we take the training sample for 2000. Just open the imagery. Suppose 2000, this is the imagery for 2013. Then we take the training sample for 2013, vegetation, water body, sand, and build up. Just take the training sample and make the land use land cover map for 2013. Okay, same process we also apply another imagery 2023. So for that, just we take the training sample for vegetation 2023, water body 2023, sand 2023, and build up 2023. Just take the training sample from imagery of 2023 and then make the land use land cover map 2023. Okay, so after creating this 2-decade land use land cover map, now we talk about that change detection analysis, how we can easily make the change detection. So let's go. So first of all, we can perform the change detection 2 type. First type is that single change detection. Suppose single change detection, basically suppose I want to focus only for the urban area. Okay, I want to make the single class urban change detection between this time period 2013 to 2023. So single class change detection, it can be vegetation change detection or any single class. Just we concern only for the single class. It can be vegetation, it can be build up, or it can be urban, anything. Okay, just for the single class. Suppose in this class, total 4 class in our map, but I want to make the change detection only for the single class. Suppose I want to work only for the build up. Suppose when you work with urban expansion or urban development monitoring, then we need to work with only for the urban area or build up area. Suppose in this case, first of all, I will try to show you the single change detection for urban. Then we talk about that multiple change detection. Multiple change detection, basically it including all of class at the same time. But when you work with single class, then we just talk only for the single class. Suppose I want to make the change detection only for the build up, area I want to focus. How much build up area increasing between this time period 2013 to 2023, and build up change detection area we also consider. Okay, so let's go. So first of all, you need to just identify which variable stored the map, this map and also this map, which variable stored this 2-decade land use land cover map. So this map already stored in a variable. Okay, so this variable we need to identify for land use land cover 2013 and land use land cover 2023. Okay, so these 2 map already stored in a variable. So let's go try to check the variable name. Then we can easily, you can see that this is the classified. Okay, this is the one kind of variable. This variable is stored the layer land use land cover 2013. Okay, land use land cover 2013. So this map is stored in this variable. Okay, and this map is stored in this variable. Okay, classified and classified 1. So you can see this variable we find out. Okay, so to 2013 this map is stored in this variable classified, and 2023 this map is stored in this variable. So this is the first step. So first of all, we need to check which variable is stored the map. So we find out that 2013 is stored in the classified and 2023 it stored the classified 1. So after checking this variable, now we just work with that, because we showed that this 2000 and 2013 stored the classified and classified 1, these two variable. So now I want to work for single class. Suppose I want to work only for the build up. Okay, so just you can take a variable. Suppose I put the variable name is the build up area 2023. You can put any name as a variable and then call the classified 1, because the classified 1, this variable stored the map land use land cover 2023. So this map is stored in this variable. Okay, so from this map I want to work only for the single class of urban. Okay, so if you check what is the value of build up or urban, from here you can see the build up, just click on here, you can find out the value is the 3. Okay, so build up, this value is the 3. So now we simply put here EQ, we can see EQ means equal, then put the 3, number of class, number of value of class. So we find out the 3, because 3 is for urban. So now I want to display the layer of only for the urban. So just add the layer. So in this time we create a binary class basically 0 and 1. Binary class where there is no urban, it shows the gray color, and where this is urban, it shows the red color. Basically urban and non-urban we find out in year of 2023. So let's check the result and check the result. Just I run the code. So now it's create the another layer urban 2023, and it's including only for the urban and non-urban in year of 2023. Okay, so now if you check this layer, just I uncheck other layers. So we find out this is the map. Basically this is the one kind of map. This map display the urban and non-urban. Okay, so urban area show as a red color. Okay, and non-urban show as a gray color. Okay, this type of gray color, it means that there is no urban, it's another class. But this type of red color, it's indicating about the urban area in year of 2023. Okay, suppose I want to make the map single map for vegetation. Suppose I want to put the map for vegetation. So how I can create for vegetation? So you need to check what is the vegetation value. Vegetation value is the 0. Okay, so now you can simply put here the 0. 0 is the value of vegetation, just put the 0. And now I want to put the vegetation color as a green. Okay, just put here the green, and gray non-vegetation area, green vegetation area. So just run the code. So now it display the map of vegetation in year of 2023. So this is the one kind of process to make the single class map. Okay, so now you can see it working. So now we find out this type of green color. Okay, this type of green color is indicating about the vegetation area. Okay, in vegetation area in year of 2023. And this type of gray color, it's non-vegetated area. Okay, it's other class, it's not vegetation. Basically vegetation and non-vegetation we can easily create. So any classes, just simply put the value, then we can easily make the single class map. Suppose I want to create the map for sand land. You can check the value for the sand land, value for 2. So now if I just put here the class 2, and sand land I want to show as a suppose yellow color. Okay, just I put the yellow color, just run the code. So now we find out only for the sand land in year of 2023. If you check the result for the first layer, so now this type of yellow color, it's indicating about the sand land. Okay, and this type of gray color indicating about the non-sand land, it's the another class. Okay, so this is the way we can apply and create the single class map. So in this case I want to make the urban change detection. So now I want to work for the urban. Sometime you need to work with vegetation change detection or water body change detection for single class. Okay, for the different class, then you can simply put here the class value number. So I want to work for the build up. If you check what is the build up is for 3. Just I keep put here 3. equal to 3, and I would display the build up area as a red color. Just put here the red and run the code. So now we find out that build up area in year of 2023, because this variable classified one, this variable stored the map of land use land cover in year of 2023. So just I set equal to 3. 3 is the value number. 3 is the value number of build up. Okay, so now we can easily find out this type of result. If you check this type of red color indicating about that build up, and this type of gray color, it's the non build up area we find out. So now I want to calculate how much build up area in year of 2023. So for calculating this area, just take a variable. Suppose I put the variable name is that urban area. Okay, then I just call this build up area 2023, this variable. Okay, this variable is stored the build up area. Just call this variable and multiply this function ee.image.pixel area. So this function computed, if you check this function, simply search on the docs tab, ee.image.pixel area. So this function, you can see this function calculate the pixel area in square meters. Okay, square meters. Generate an image in which the value of each pixel is the area of that pixel in square meter. So this function basically generate a image. You can see it returned the image. Okay, so first of all I want to compute the build up area. So that's why I simply just multiply with this function. This function create an image. So from this image, you can see it show the return as an image. So from this image I calculate the total area. From this image I calculate the total area. So for calculating the total area, we already know about the reduce region function. Okay, this function reduce region. So just I apply the reduce region function. Just take a variable, suppose urban area 2023, then apply the reduce region, and then put the total area for e.sum, then geometry basically is a shapefile variable name RY, and max pixel 1 is 13, we are just used for the big study area. So now just I call the urban area. Basically this urban area, it work as the image. Okay, it work as the image. So from this image I calculate the total area for my specific boundary. So for that just use the reduce region function. Okay, I want to calculate the total area. So e.reduce.sum. So this is it calculate the total area. Geometry basically it's your shapefile variable name. Scale is the resolution of your satellite imagery. Landscape for 30 meter. So now further we just print, then we can find out that how much total area in urban year of 2023 we find out. It computed. Okay, so it's computed. We find out this type of large number. So it is a square meter. Okay, so this square meter we can easily convert as a square kilometer. So for that, just take a variable. Suppose I put the variable name is that R1 area is 2023 square kilometer. So it's a number. So it's a number, and this, so that's why I just use here e dot number, and this number is stored in this variable. Just I put the variable name, and you can see it get from this classification. Okay, just mention here get classification, and divided 1 is 6, this value. So when you divide it with this value, then we find out the result is square kilometer. So just print, and now run the code. So now it's computed as a number. We find out that result in square kilometer unit. So we find out that this is the total area 124.99 square kilometer, because I just divided. When you divide it with this value, then we can get the result in square kilometer unit. So now we find out the total area of urban. We find out the total area of build up 824.99 in year of 2023. Okay, so now I want to do for the same things for that in year of 2013. Okay, so now I want to make the urban map for this 2013. Okay, 2013. So this map is stored in a variable. We already checked this variable name is that classified. Okay, so just same process, just apply. Okay, just put the same process, just take a variable build up area 2013 and call this variable, because this variable is stored the land use land cover map in year of 2013. Okay, then set equal to 3. Theory 3 because it is stored the urban. If you check what is the value is for the 3. Okay, value for 3 for build up. So just we put here the 3, then same process we just apply, just display the map or then run the code. So now it create the another layer of urban in year of 2013. If you check, okay, so this is the map year of 2013 and this is the map 2023. Okay, so you can see, okay, this is the result in year of 2013 and this is the result for 2023. Okay, in the 2023 find out that lot of build up area increased, and 2013 you can see not much. We find out this type of result for 2013 and this result for 2023. So now let's check how many build up in year of 2013, how many build up area in year of 2013. We try to check it. So same process, just apply, just take a variable, suppose urban area, and then call this variable name, multiply, and then use the same function. Okay, so let me show you the result directly, and now run the code. So now we find out that how many build up area in year of 2013. We can easily find out the result. We find out that 586.44. Okay, 586.44 square kilometer area in build up in year of 2013. Okay, so now we can simply subtract these two value, then we can easily find out the how much build up area increased between these two time period. So 824.99 minus 586.44, we find out that 238.55. So 238, okay, 238 square kilometer area increased between these two time period. We find out, just subtract this value, you can easily get the result. But now I want to make the urban change detection map. So how I can easily make the change detection map, or how I can make the urban expansion map. Okay, so if you create the urban expansion map in Google Earth Engine, so for that we need to create the single class. Okay, basically we just apply the set, not binary class, just make the single class. Okay, so it's a binary class, we already know about that, how we can easily make the single class. So for the single class, just use the self max function. Okay, just apply here dot self max. Okay, and then remove the binary 0 and 1, just remove, and put the one color. Suppose I just put here the build up area 2023 as a red color. Okay, and same, just I put the self max function in here, dot self max, and then remove the binary 0 and 1, and then put the only for the one color. Suppose I put the color for suppose I put the yellow color, okay, for build up in year of 2013. Just run the code. So now it create only for single class, not binary class. So just we find out only for the red and yellow color, then we can easily identify for urban expansion area. So this yellow color, it's represented the urban area in year of 2013. Okay, this type of red yellow color. Okay, this type of yellow color represent the urban area in year of 2013. But this type of red color, it's indicating the urban expansion area. Okay, urban expansion area. This type of red color, it the urban spiral or urban expansion. This type of red color indicating about that. Okay, this is the urban area in 2023. Okay, in the 23 find out this type of place expanded of urban or build up, okay, or urban development. This type of place is the red color. But in year of 2013, this type of yellow color, okay, this type of yellow color indicating the urban area in year of 2013. But in 2023 we find out that this type of red color expanded as the urban area or urban development area in year of 2023. Okay, and how much area expanded, so this expanded area we can easily calculate it. Just simply subtract these two value, this value, this value and this value. When you subtract, then we find out that almost 238.55 square kilometer area expanded between this time period 2013 to 2023. Okay, so 2013 to 2023, how much build up or how much urban area growth, we find out the 238 square kilometer area, and this type of red color is the expanded area. Okay, this is the expanded area, this type of red color. Okay, this type of place there was no urban in year of 2013. In year of 2013, this type of place there was no urban, this type of red color. Okay, so this is the way. So in this time I just consider only for the two decade 2013 and 2023. If you want, you can also add the more decade. Okay, to make the temporal analysis, you can also add the 99, then 2000, 2010, 2015, 2020, different decade you can easily add and make the more analysis or more temporal analysis. But in this example, just I show you only for the two decade 2013 and 2023. But when you apply the more decade, just apply the same process. Okay, just apply the same process. So in this time we make the urban expansion map between this time period 2013 to 2023. But if you want, you can also add the more different decade and make the more temporal analysis. You can also add, and then it will look more better. So now we find out this type of urban expanded area in year of 2023, and how much area, we find out the 238 square kilometer area. So now if you check this type of place, it's the urban area, and 2013 we also find out the urban area. Okay, 2013 there was urban area, and 2023 it also urban area. Okay, so there is not change. Okay, this type of yellow color, it was urban in 2013 and also urban in 2023. So this type of place there is no change, it's an unchanged area. Okay, basically we find out this type of yellow color, this type of red color. Okay, this type of red color we find out that it's a newly set up urban area or new expanded urban area. So now we try to make the change detection. You can check, just simply subtract. Okay, just I make the binary class and then show you the result again. But when you make the expansion map, then just make the self max function, then you can easily it look more better. Okay, so now for the change detection, just simply take a variable, suppose urban changed map, I just put, and call the build up area 2023. Just call this variable name build up area 2023. Just call, and then subtract with build up area 2013. Okay, build up 2013. So now if you check, just I run the code. So now you find out that urban changed area. So now you can see, find out that this type of place, it urban changed area between this time period, because this type of pink color, it's indicating about that there was no urban in year of 2013, but 2023 we find out the urban, this type of pink color. Okay, it's indicating about the newly set up urban area we find out. And in this time, suppose it the changed area, okay, let me show you the binary class, then you can get the more better idea. So just remove the self marks. I just put here suppose two class. For that I put here min 0 and put here that max 1, and I want to display the pink color for changed area, and also put here suppose white color for unchanged area. So then it look more better. Changed and unchanged area of urban we find out. Okay, white color represent the unchanged area and pink color represent the changed area of urban between the time period 2013 to 2023. Okay, so here you can see, find out this type of white color, it's indicating about the unchanged of urban area. Okay, and this type of pink color, it's indicating the changed of urban area. So this type of place, there was no urban or there was no build up in year of 2013, but 2023 we find out the build up or urban, this type of place. Okay, this type of place we find out this type of result in here. So it's one kind of urban changed map. Okay, you can easily export as a geotip file format, and you can also represent. Not only for that, all of layer we can easily export as a geotip file format, and further just use the ArcMap or QGIS software to process your research paper map or your presentation map. Okay, same process you can apply. So now you find out that urban changed map look like that. So this type of pink color is the changed area, and this type of white color is the unchanged area. Okay, so anyone in question, you can ask me please, or any confusion about the urban changed area, you can ask me
Yes.
please.
Yes. Thank you so much for the enlightenment. I have not a question, but just maybe an inquiry. Assuming I'm interested in doing assessment for a yearly change detection, not a decade. Let's say from 2013 to 2014,
Yeah,
2014 to 2015, just after 1 year, every year up to 2025, right?
yes.
Uh, is there any way we can just apply a single code, just one code or 2 lines of code, so that it just generates the whole map?
Yes, it also
Is it
possible. Yeah,
there?
it also possible. So this code you can also modify some time. You can see here in this time we are just put here the 2 decade. Basically, we just make the land use land cover map for the 2 decade 2013 and 2023. Okay, so same process we can also apply. You can see here I take this data set for 2013. Okay, this data set for 2023. So now I can take the data set 2024. Okay, make the data set, or suppose make the another data set for satellite image collection 2024 or 2025 or 2020 or 21. Okay, then we are just make the data set. Okay, then make the land use land cover map. Okay, so before making the urban change detection, or just we need to create the land use land cover map. Okay, this type of yearly land use land cover map. So in this time I just put here the 2 year. basically 13 and 23. Okay, I take. But if you want, you can also make the temporal for yearly. Okay, 2000 or 2001, 2002, 2003, like this. Okay, just make the land use land cover map. Okay, and if you create the land use land cover map, then you can easily make the change detection. Okay, same code just you used and make the land change detection easily. Okay, but first of all we need to make the land use land cover classification for yearly. Okay, 2000, 2001, 2002, just make the land use land cover map for yearly, then we can easily make the change detection or urban growth monitoring or urban expansion mapping. This type of things we can easily do for yearly. It also possible do that. But when we apply the supervised learning, then we need to take the training sample for each year. Suppose you can see, first of all I take the training sample for 2013, then take the training sample from the imagery of 2023. Okay, suppose you make the another year 2000, then take the training sample from year of 2000. Suppose 2001, same process, but every time we take the training sample, getting the more better land use land cover mapping. Okay, it also possible, suppose I just take for only one time, suppose I take the training sample only for this image, only for the image 2013, but then I apply all of imagery. It also possible, but for this case we don't get the better accuracy, we don't get the better land use land cover map. Okay, because it also changing. Okay, so that's why when you take the imagery, every time we need to take the training sample. Every time, suppose 2013 we take the training sample, from 2023 imagery we take the training sample, every year we take the training sample, and then make the land use land cover map. It will be more better and we can find out the more good accuracy. Okay, otherwise it also mixing or land use land cover map is not good. So that's why when you make the yearly, then try to take the training sample. Okay, individual imagery, suppose for 2013 we take the training sample, then 2023 take the training sample, then also take the for the other yearly imagery, same process, then make the land use land cover map and then make the change detection. Okay, so in this case we are just taking only for the 2013 and 2023, so that's why we are just make the change detection for this. But if you want, you can also yearly, suppose 2001 to 2002, 2002 to 2003, like this we can also make the change detection, same way, same process. Okay.
Wow, thank you.
Yeah.
Thank you so much. Understood.
Yeah. Okay, so now we find out this type of, if you check, this is the urban changed map. Okay, this type of place is the changed area, and this type of white color is the unchanged area. Okay, and we already calculated, just subtract this value, then we can easily get the result. How much area? 238 we find out. So if you check, okay, so now we try to check the urban changed area in Google Earth Engine also. If you want, you can also just subtract this value. This is the result for 2023, this is the result for 2013. Just simply subtract this value 2023 to 2013, then we find out that 238 square kilometer area increased. Okay, so this thing we can also further, we can also calculate it in here. So basically this is this variable is stored the changed and unchanged map. So just we try to calculate. So just take a variable, suppose urban change area, then call this variable name, multiply with this function. So now this variable is stored an image, this image have a pixel area. So now from this image we calculate the total pixel area. So for that just use the reduced region function. Okay, so just apply and calculate as a square kilometer, same process, just apply. And max pixel is scale for the 30 meter. We try to put the because it's a Landsat imagery, so now run the code. But sometime if you want to work with lot of pixel, then it's not work. Okay, for the computation is not work. So let's check what's happened. Okay, we can see we find out this type of problem. So it's a common problem, user memory limit exists. So when you work with lot of pixel, it's not computed. So then if you just increase the scale value, if you increase the scale value, then your it reduce the pixel number. Okay, Suppose if I put the 100-meter pixel size, then it reduce some pixel number and compute it, but it not accurate. You can see we find out the another value because our satellite image pixel size 30-meter, but I put the 100-meter. Okay, so then you can see we find out the it also coming the result, but this result has some error. We find out because it will be just if you subtract this value, then we can easily get the result 238 point something, but now it show the another value because we change the pixel size. Okay, we find out the 228. Okay, but it was 238. Okay, 238.55, because if you simply subtract this value, this is the result for 2023 and this is the result for 2013. If you just simply subtract the value, you find out the 238. But now when I computed the urban changed area, how much area urban changed, it show the 228.31 because I just increase the pixel size. Okay, because when I put the 30-meter, there the lot of pixel number and then it not computed, it show the user memory limit exist. So then when I increase as a 100-meter pixel size, then we find out the result 228.31, but accurate result will be 238. When you subtract the value, then we find out the 238. Okay, so this is the one problem. But when you just calculate the area in the ArcMap or QGIS software, then it will be look more better. Otherwise, you can see in this time it shows some wrong. It show the 28, but it will be 238. Okay, so this is the our changed area, urban changed area. We find out. So this is the process when you work for single class change detection. Okay, so now if you want to work with suppose another class, suppose I want to work for suppose sand area. Okay, I want to check how much sand area increasing or decreasing, this type of things. Just simply put the sand value or vegetation. So let's go try to check for vegetation. What happened? Vegetation, what the value for vegetation is the 0. So just put here the 0 value, just put here the value 0 and then put here the green. Okay, put here the I put the vegetation color as a green, and then same, just put here the 0 and put the vegetation as a green. So now we are just run the code, then it will be show the result for vegetation changed area. We can easily find out. Okay, it's a layer name. Layer name doesn't matter. Okay, it's a layer name. We can put anything, no problem, as a layer name. Okay, so you can see find out this type of place. It's the vegetation changed area between this time period 2013 to 2023. And if you check the map, so this is the result for 2023 and this is the result for 2013. Okay, we find out, and if you check, we find out this type of change, vegetation changed area, this type of pink color, and this type of others is not changed area. And how much area we find out, you can see we find out that 15.79 square kilometer vegetation area changed. We find out that 30, okay, and 49. Okay, so this place also increasing the vegetation between this time period. Okay, so this is the result for 2023 and this is the result for 2013. Okay, this is the vegetation. Suppose I want to check for sand land. Okay, sand land. So if you check what is the sand land value is for 2. So just put here the 2, just put here the 2, and sand land I want to show as a suppose yellow color, and then also same for this year, just put here the 2 and sand land I want to display as a yellow color. So now we can easily find out the sand land changed area, how much sand land changed between this time period. We can easily find out from here. Okay, so now you find out this type of pink color, it is the urban, it's a sand land changed area. Okay, if you check, so this is the result for sand land 2013, it's a 2023. Okay, and see lot of sand land changed, we find out. Okay, you can see, and this is the sand land changed area. So you find out this type of place, this type of sand land changed between this time period, and how much sand land changed, we find out total area. You can see the decreasing 239.33. So this type of sand land loss between this time period. Okay, because it shows the negative mainly loss area, we find out that. So 239.33 square kilometer sand land loss between the time period 2013 to 2023, we find out that. Okay, so this type of, you can see it show the minus, it means that it's a decreasing or loss between this time period, this type of sand land. And how much, you can see this type of place. Okay, this type of place changed, and how much changed, we find out that 239.33 square kilometer area decrease. Okay, so this is the process to work with single class change detection. So any single class, it can be urban, vegetation, or water, or sand, or build up. Okay, just simply put the value, then apply the same process for making the single class change detection. So now we talk about the multiple class change detection. So multiple class change detection, basically at the same time all of class, suppose vegetation, then water, then sand, and build up. So all of classes, we make the change detection for all of classes. So let's go try to discuss about that, how to make the multiple class change detection and make the transition area. So how much area increasing or decreasing. So when we apply the multiple class change detection, first of all, we need to apply the reclassify. Okay, so reclassify, basically we set the value vegetation for 0. Okay, then water 1, then 2, then 3. Okay, same, then 0, 1, 2, and build up for 3. So first step we need for reclassify, just change the value 0 to 3 into 1 to 4. So now vegetation will be 1, then 2, then 3, and 4. Okay, just we make the reclassify. So this is the first step when you make the multiple class change detection. Okay, so this is the 0, then 1, then 2, and 3. So when I reclassify, then vegetation will be 1, then 2, then 3, and 4. Same, it will be 1, then 2, then 3, and build up will be 4. So this is the first step, reclassify 0 to 3 to 1 to 4. So how I can easily make the reclassify? So for the reclassify, just we take a variable. Suppose I put the variable name is the before class mainly in year of 2013. Okay, 2013, it's a before class. So I take a variable before class and call the classified, because this variable stored the land use land cover map of 2013. Okay, this map, this land use land cover map is stored in this variable. So now I want to make the reclassify. For the reclassify, just use here the remap function. Okay, it just reclassify the value. So this is my previous value 0, 1, 2, 3, 0, 1, 2, 3. It's a previous value. When I put in here, you can see 0, 1, 2, 3. So this value I convert into 1, 2, 3, 4, 1, 2, 3, 4. So just I put the new value. So when I put the remap function, so now 0 will be 1, 1 will be 2, 2 will be 3, 3 will be 4. So now vegetation is the 1, then water is 2, sand is 3, build up is 4. Okay, when I apply the remap function. So same process you also apply for 2023. Okay, just apply for 2023. Basically this land use land cover map 2023, and classified 1, this variable stored the map land use land cover 2023. Okay, just I call this variable name and apply the remap function, then put the previous value, then put the new value. Okay, so this is the first step for reclassify when you make the multiple class change detection. So in this case I have only for the 4 class. Suppose you have 5 class, 6 class, same process. Okay, suppose in the I have total 5 class, and suppose there 4. Suppose I have the another class for 4, then just put here the 5 in here. Okay, so in this case I have only for the 4 class, I don't need this type of value now, but sometime when you work with the 5 class or 6 class, the same process will be increasing. So just we remap 0 to 3 to 1 to 4, both of land use land cover classification map. So now I want to make the change detection. Okay, so change detection, for that just take a variable, I put the changed after class basically 2023 subtract with before class basically 2013. Okay, and then we try to just apply the changed. Okay, and it show the overall changed and unchanged area. Okay, so white it represented the changed unchanged area, and red is represent for changed area. Okay, overall changed and unchanged, it including all of classes. So now I find out this type of white color, it is the unchanged area. Okay, this type of red color, it's a changed area. Okay, so it shows the overall changed and unchanged area between the time period 2013 to 2023, overall changed and unchanged area. So this type of white color, it's unchanged. Suppose it was built up in year of 2013 and to 2023 it also built up, so there is no change, it's unchanged area. Okay, suppose this place in year of 2013 it was sandland, but 2023 we find out the build up, so it's a changed area. So this is the overall changed and unchanged area map between the time period 2013 to 2023. Okay, so then, okay, so now we try to calculate about the transition mainly. Suppose vegetation to vegetation, how much area, or vegetation to water, suppose how much vegetation convert into water in year of 2023, or how much vegetation convert into 2000 sand in year of 2023, how much vegetation convert into build up in year of 2023. So it's called the one kind of transition. Suppose how much water body convert into water in 2023, how much water body area convert into vegetation in year of 2023, or how much water body convert into sand in year of 2023, or how much water body convert into build up in year of 2023. Okay, so this type of transition, suppose sandland to vegetation, so how much sandland convert into vegetation in year of 2023, or how much sandland convert into water in year of 2023. So this is the one kind of transition. So how much build up convert into vegetation, how much build up convert into water. So now this type of thing, so it's a before class and it's a after class. Okay, so this is the before class, before mainly 2013 and after mainly 2023. Okay, so this is the before and this is the after. So just we make the conversion transition before and after. So for that we just apply a formula. So this is the formula, it's called the transition formula, transition area calculation formula. This formula is look like that. Just take a variable and then before class basically 2013 and after class 2023. So before class I already, you can say I already make the before class. Okay, just call the before class, multiply with 100 and add with after class. After class I already make the after class, this is the after class. Okay, so before class basically 2013 and after class for 2023. Okay, multiply with 100, add the after class and rename it as a transition. So now if I just print the, we find out the one image and it's called the transition image. If you check it, the image computing, and it's called a transition, it's a transition image we find out.
Excuse me,
Yeah, please.
why are we multiplying by 100?
Okay, I explain about that. So this 100, it's one kind of formula. So in this time, if you check after multiply 100 and add with after class, then we find out this type of value. Okay, you can see it show the transition, and it including this type of integer value belongs with 101 to 404. Okay, 101 to 404, it's including the 101 to 404. So 101, then 102, 103, 104, then 201, 202, 203, 204, then 301, 302, 303, and 304, and finally 401, 402, 403, and 404. So now it's indicating about that this type of number. Okay, one it's a before, and this one is for after. Okay, so this is the before class. Before basically 2013 and after 2023. Okay, so this one and this one. So for that we are just put the 0. It just show this right side, left side, it's a before, and this left side is a after. Okay, so for this 0, for need this 0 value, we just apply the multiply with the 100. Okay, for getting this type of value 101, 102, 103, 104. Okay, so that's why you just multiply with 100. Okay, and when you multiply with 100 and add with after class, then we find out this type of value 101, 102, 103, 104, and this one it's the before year and it's the after. Okay, this one is for the before and it's the after. And what is the one? We already know about that. This now vegetation is the one, because I already make the reclassify. Okay, so before class and after class, basically these two variable is stored at the reclassify. Okay, so now 0 will be 1, 1 will be 2, 2 will be 3, 3 will be 4. So now vegetation is 1. For my case, vegetation is the 1, then it's a 2, then 3, and this is a 4. Okay, so now if you check 101, it means that vegetation 2013, basically before, to vegetation 2023. Okay, it's after. Okay, after year, this is the before year and this is the after year. So 102 means that vegetation to water. Okay, then 103 vegetation 2013 to sand 2023. Then 104, it means that vegetation 2013, basically before year, and after 4 basically build up 2023, because I already make the reclassify. It's a 1, then 2, then 3, and 4. Okay, same process. Then 201, then 202, 203, 204. Then same process 301, 302, 303, 304. Then 401, 402, 403, and 404. So it's called the transition class. Okay, so to get the transition class, we are just multiply with the 100 and add with after class. So now we find out this type of, you can see this type of transition belongs with 101 to 404. Okay, this symbol means that including all of those, it starts from 101 and end 404. Okay, and 101, 404, it has a one kind of meaning. So this meaning is that vegetation, how much vegetation convert into vegetation, how much vegetation convert into water in 2023, how much vegetation in 2013 convert into sand in 2023. Okay, how much vegetation convert into build up in 2023. Okay, so it's one kind of transition. And when you
Okay.
yeah, so
maybe just to confirm, is it like a variable holding vegetation changing from 2013 to 2023? 101, 102, are those variables? How about if I say 201, 202, 203? Will I multiply with 200? Just to confirm.
okay, so basically when you just apply this formula after reclassify, when you apply this formula, then we can automatically get this type of value 101, 102, 103, 104. But for my case, what is the one for vegetation? Okay, because previous time we can see before the remap 0 is vegetation, but when I apply the remap function, then 0 is 1. Okay, so 1 is vegetation, then 2 is water, 3 is sand, and 4 is build up. Okay, and for a same case for 2023 for classified one, because it stored the land use land cover 2023. So same case, so 0 will be 1, 1 is 2, 2 is 3, 3 is 4. So now this vegetation is the 1, then 2, then 3, and build up is 4. Okay, and when we apply the transition formula, then we automatically find out this type of value 101, 102, 103, 104. Okay, we automatically find, you can see it automatically show you this type of value. So
Okay.
now what is the 101? One for my case, one is vegetation. Okay, so then you can simply, okay, so now we try to calculate the transition area, then you can easily get the idea. So before the transition, we compute the how pixel number. Okay, transition pixel number we computed. Transition pixel number we computed. So for that, we are just applying the frequency histogram function. We are just applying the frequency histogram function. So let's go try to apply and run the code.